Hello. So this is your overview lesson for 2.4 linear models. This is going to be dealing with linear or straight lines, but word problems. All right, page 1, you want to kind of read through it, get yourself an overview. No work to do other than review. Page 2. Don't worry about this video. It's not as good as the lower part. So what we're talking about here is, here's the situation. You are trying to save for a summer camp. You start with $25 from your parents and $25 of your own savings. Every week you save $40 and you have 7 weeks to work. You want to go through these slides using the study guide or a piece of paper so that you can kind of get all the different parts of this problem. So to track your savings, what do you need to know? You want to know how much money you have at the end of each week. Moving through, the first thing you want to do is make a table so starting from week 0 where you have the money and then going each week before camp starts. So your table would look like this. Here's week 0. You start with $50, 25 from you, 25 from your parents, and you're making $40 a week for 7 weeks. Then, so you looked at that table, your independent or your X variable. So going back to the table, your X are your weeks. Okay, so the independent variable are your weeks. The dependent variable is your f of x or your y, which hopefully from the table you'll remember is the amount of money that is saved. So can you look at a table and give the words for what you're talking about? Moving on, is this a relation or a function? So remember from previous lessons, when we look at a table, we look at the x's and you look to see if there's one x for every y. Or do the x's repeat? No, they don't. So it is a function because, and this is the nice way of saying the x's don't repeat, for every value of x, there's only one value of f of x. But because it is a function and it forms a straight line, it is linear. The domain and range, domain are what are the x values, range are what are the y values. So the domain is the passage of time from 0 through week 7. So the domain is the integers 0 through 7. You say integers because we're not counting half weeks. Integers are whole numbers. Okay, the range is the amount of savings. So how much money you made. You start with 50 and you end up with 330. So here we have to give all the exact numbers because we're not earning amounts in between each week. We're talking about at the end of each week, how much are they earned? So you can't just say from 50 to 330 because I could say 55 is part of the answer then, and it's not. Okay, so on the next page of the study guide or in your notebook, this would be what the graph is, and you'll notice that there's no connecting of the points. That is because we can't have answers in between these points. When you connect it, that means you're saying all the numbers in between the points are part of the answer. And in this case, they're not. It's 50, it's 90, just these numbers, so they cannot be connected. So then we're talking about that equation, starting with $50 and adding 40 each week. Because we're starting with $50, that makes 50 our B, our initial amount. Because we're going by 40 each week, that makes our slope of 40. So your equation would be f of x equals 40x plus 50. The next slide talks a lot about being in context. If you remember from last year, in context means you have to use words from the table or from the word problem when describing these key features. And all the key features are right here. So if you're using your study guide, this is what's going in the list. X-intercept, Y-intercept, domain, range, and intervals. Intervals are pieces of the graph that you section out. Okay, using that, then we look through the satellite slideshow. You're going to use these arrows right here to kind of click through, and you're going to answer these questions in context. So After being launched into orbit, a communications satellite stays in place above the same spot on Earth by moving through space at the same speed as the rotating Earth. The satellite uses a small amount of power each day to maintain its constant height above Earth. When the power supply on board is used up, the satellite is no longer functional. The graph on the right shows the amount of power per year. So here's the graph that you're going to be interpreting. If you've got the study guide, you'll see that there's like 6 questions for you to answer. As you go through these, okay, it shows you what they're talking about and it shows you the answer. So the first question talks about the y-intercept. The y-intercept always represents the initial value. Well, in context, the initial value is right here. So that means the starting value is 100 units of power for the satellite. The x-intercept is where it crosses the x-axis. Okay, so that reveals the time when, so that means in context, the function has 0 units of power during year 10. Moving on, you keep going and you read through here to talk about the domain. The domain is talking about the x values or the years. So the satellite only has power for 10 years. Just this top part right here. And the range is talking about the y's or the units of power. So the satellite has 100 units of power until it gets drained. That's how you put the range into context. When we're talking about the slope, we're talking about the rise over run. So if I start here at this point and I go to the next point, okay, you'll have to pay attention to the numbers because that's not 1. That is from 100 down to 80. That's negative 20. And then I go over 2. Okay, so down 20 and to the right 2. That this slope of negative 10 came from negative 20 divided by 2, which equals 10. So that means for every year, this is how it's in context, for every year, the function loses 10 units of power. That is how you write a slope in context. Okay, so is this function increasing or decreasing? It's going down, it's decreasing. So hopefully that makes more sense. That's like the big part you want to do on this page. And we will then move on to slide 4. All right, finding average rate of change. So the formula you want to focus on is this formula right here, okay? F of B minus F of A over B minus A. If you're trying to figure out what that is just like, that is just like the slope formula, y2 minus y1, x2 minus x1. The only thing is that with the rate of change, you kind of have a specific y1 and a y2 you want to do. Okay, so when they give you like a data chart, they're going to say rate of change instead of slope because it doesn't always go exactly. So your years are your x's, your costs are your y's. You want your very first one to be x1 and your very last one to be x2. You want your very first y to be y1 and your very last one to be y2. Okay, it's important that you do that top to bottom. Don't mess around with the ones in between. Okay. Moving through, it shows you how they set it up using the y1s and the y2s, and how they got 30.39 over 42, and then they divided it and got that as the answer. They got a positive slope, so the change is increasing. So there's a spot for you to write that down on the study guide. Okay, vertical shifts. So they start off by giving, you can try this in your calculator. Your original function was f of x equals 5x. The new function is 24. What happens when we add those two together is that you get a new function of f of x plus 24. So if you were to put both of those on a graph with your calculator, you could use the y equals button. Right here, the blue is the original one. When we added the 24 to it, it moved up. Okay, so you'll notice that right here we have a new y-intercept of 24, so the graph moves up. The same thing happens if it was to be, or the opposite thing is more exact. If it was a minus 24, the graph would move down here somewhere, and you would see points down here. So a vertical shift will move a graph up or down. All right, there's some spots right here where you can try it. Okay, so if I have 40x and I just have 40x plus 25, what could that mean in context? All right, there's a vertical shift. So it affects the initial amount. So instead of starting with 0, she would start with 25, or he. All right, so you want to try some of those to see if you're understanding what we're talking about. The last bits of slides are all practice. Okay, so there's some 3 problems on here for you to try. The first one says the speed of sound at 0 degrees Celsius is approximately 101 meters per second. Which function below shows how far a sound will travel in X seconds? So you would see which one you think is the right answer and hit submit, and then keep going and try those problems. Page 7, again, are 2 more practice problems. There is a spot for you to write down your answers in the study guide or on a piece of paper because these have a lot of pieces. Given this situation, you're about to start a 10-week summer job, getting paid weekly, working 6 hours a week. You'll be earning $8 an hour. You currently have $50 saved. Determine the key features, x, y-intercept, domain, and range. Determine the function and sketch the graph. If you click here, you can check your answers. Number 2, given the following table that represents the distance a walker is away from her home as she is on a morning exercise, the distance is a function of the time spent walking. Use the table to determine where the function is increasing and decreasing. Calculate and interpret the average rate of change. That's that y2 minus y1. Again, check your answers. Last page, as always, is a review. If you're still struggling or have specific questions, please contact your teacher and we will help as much as we can. Good luck on the quiz, guys.